Okay, I would like to say thank you to Aaron, Andrea, Zixian, Harvard, Sheena for submitting your online worksheet. Okay, so let's start. Now, Anya has a liquid which boils at a temperature of 100. So he wants to find out whether this liquid is water or not. So what other property will prove that it is really water? All right. For this one, most of you got this right. Except for Andrea and Sheena, you all chose C. Okay, you see, it's okay to make mistake here, but I'm going to prove to you that I can have mixture of alcohol and water. All right, so okay, let me give you one example of alcohol. There's so many different types of alcohol. So ethanol is a type of alcohol, all right, mixed with water. Okay, so I have two things mixed together. Now, if I were to boil it, right, ethanol at 78 degrees Celsius, ethanol will boil off, and then later at 100 degrees Celsius, water will boil off. So if both liquids boil off, I will not have a residue. It does not leave a residue when boiled. So, but yet it is not pure water. It is ethanol mixed with water. It's definitely not pure. All right. So the one that will prove that it is pure water is the freezing point. So in order to know that it's a pure water is it melts at a fixed number, 0 degrees Celsius, or you can say that it freezes at 0 degrees Celsius. Melting point and freezing point is the same number, or you can write boils. Boils at, what number is the boiling point? Or I can even write condensers. Can y'all tell me what is the temperature for these two? Boiling point and condensation point, what is the number? Type into the chat. What is this temperature here? What's the boiling point of water, everyone? Okay, 100. Okay, well done, Harvard, Andrea. All right, so boiling point is 100 degrees Celsius. Condensation point also at 100. All right, so please take note. Something is pure if it has a fixed melting point. If it has a fixed freezing point, fixed means only one number, or you have a fixed boiling point, or if it has a fixed condensation point, then you know that it's pure water. Is everybody clear? All right, so one of these will show that it's pure. All right, so answer is A. Any questions so far? All right, now neither acidic nor alkaline will not, because sometimes I can have, for example, water, I can have sugar water, it is still a salt solution. Let's just say seawater. Seawater is a mixture, right? It's not pure water. All right, it's not acidic, it's not alkaline. All right, so it's not acidic, it's not alkaline, it's neutral. All right, and yet seawater is not pure water. Okay, then pH 7. So same thing here, seawater, the pH is also 7, but yet it's not pure water. All right, so the answer is B. Okay, so anything that is pure, it has a fixed melting point, fixed boiling point, fixed melting point, fixed freezing point, fixed boiling point, and fixed condensation point. All right, clear? Okay, let's move on. Okay, before we move on, right, then it is maybe to the heating point. So I just show you heating curve is drawn like that. I hope you're able to draw on your own. So slope, horizontal, and then slope, horizontal, and then slope. All right, so this, everybody type in the chat, the first slope is what? What process is this? Type into the chat. What is this? This one is temperature, and this is time. Okay, good job, Andrea. The rest, what is this question mark? Good job, Harvard. Aaron, this is a heating curve. So should it be freezing or melting? All right, so this is a heating curve. All right, compared to cooling curve. Okay, good job, Aaron. All right, so this has to be melting. And this horizontal line is, anyone unmute yourself or you want to type? Okay, good job, Andrea. The rest, what is this one? Has to be boiling. Okay. And then the slope, right? So basically you will, let me admit someone. All right, so this part, the three slopes, right? You will be the three states. So you will have solid, liquid, and gas. All right, so in the same way, I can also draw the cooling curve. So I have temperature and then time. So I have one slope, horizontal line, another slope, horizontal line, another slope. So let me highlight the three slopes. So this slope, and this slope. So can everybody name me what is the first slope? What should I start off with? Can you type into the chat what is this slope? What is the physical state? No, what is the physical state? The yellow one, this part, the yellow highlighted one. Good job, Harvard. Good job, Aaron. Good job. Hang on, what's the first name? Block. Okay. Harvard, Andrea, Aaron, correct? All right, so this has to be gas. All right, because you cool down a gas, then become a liquid. You cool down a liquid, becomes solid. All right, so please remember the slope. We have solid, liquid, gas, slope. And then if it's cooling curve, it's gas, liquid, solid, the other way around. All right, then what about this horizontal line? Can you all type into the chat? What is the name of this process? What's the name of this process? All right, this one. All right, well done, Andrea. Well done, Hubbard. The rest? What is the name of this change? Okay, short of one letter, okay, then. All right, then is D-E-N, like the lion den or the bear den. All right, condensation. So this is condensation. And then the other horizontal line, everybody type in the chat, what is this horizontal line? What physical process is this? Okay, well done, Andrea. Okay, well done, Hubbard. All right, so it's freezing. Okay. So in the exam, right, you may be given just one part of it. You may be given slope, horizontal slope. All right, or you may be given this part, slope, horizontal slope from liquid to gas, or you may be given solid to liquid, or you may be given both. All right, and then do take note of the state. So for melting, it will be a mixture of S plus L. How about boiling? Boiling will be a mixture of what? During during boiling, what states do you have? During boiling, what states do you have? Okay, liquid and gas. Andrea, there should be a mixture of two states. All right, liquid plus gas. Why two states? Is because some liquid has not yet boiled, it is still a liquid, but some liquid has already boiled, then it become a steam. So that's why during boiling process will take some time. That's why you have a mixture of liquid and gas, because some liquid is still in the process of boiling, it has not boiled yet. All right, so some liquid has boiled into a gas, some liquid has not yet boiled. So during boiling, you have two states. All right, you have two states. It's a mixture of liquid and gas. All right, so it's very easy to get this. This is S, this is L. In between will be S plus L. If this is L, this is G. In between will be L plus G. Let's take a look here. This is G. This slope is G. This slope is L. Can everybody type into the chat what is a state found during condensation? Type into the chat what states will I have during this horizontal line. Okay, well done, Andrea. The rest, well done, Harvard. Well done, Kaden. I have 5, now I have 6 people. I'm waiting for 3 more. What state do I have during condensation? All right, so I will have gas plus liquid. Okay. Zixuan, it should be both gas and liquid, because some gas has not yet condensed, but some gas has condensed into a liquid. So you have both. You have both at the same time. All right, so during condensation, you have both states. You have gas state and liquid state. Some have already condensed, some have not yet condensed, so you have both. All right, how about this horizontal line? Can everybody type into the chat? How about this horizontal line? What states do I have? Right, what states do I have during this horizontal line freezing? Okay, well done, Andrea. Can I see answers from the rest? Zhishen, what's your answer during this freezing? Well done, Kaden, Harvard, Andrea. How about Zhishen? Okay, well done, Zhishen. All right, I have 4 answers. I'm waiting for 2 more. Who has not responded? Aaron, where's your answer? And then I have Sheena, where's your answer? Okay, Aaron is correct. Left with Sheena. Sheena, what's your answer? What states do I have during freezing? This horizontal line. What states do I have, Sheena? All right, so you should get both states, right? Liquid plus solid. All right, 2 states, because some liquid has already frozen into become a solid. Some liquid not yet frozen, it becomes a liquid. It still remains as a liquid. All right, so once you know this, my next question is, now you can tell from here is very straightforward that temperature stay the same during melting, temperature stays the same during boiling, temperature stay the same during condensation, temperature stay the same during freezing. All right. Oh, okay. Sheena, if it's still lagging, do you want to come out of the Zoom and re-enter? I'll admit you again. All right. Okay, so my next question is there heat gain during, I'm going to type my question into the chat. Okay, look at my question. Typo error, right? The word melting. So we all know that temperature stays the same during melting, during boiling, during condensation, during freezing. My question is there heat gain during melting? Can you type yes or no? Is there heat gain during melting? If I know during melting, temperature stays the same. Okay, thank you for trying, Andrea, Aaron, but wrong concept. The rest, Zhixian, also wrong concept, but good try. Harvard, also good try, wrong concept. Harvard changed his mind. Okay, this is a difficult question. So don't worry if you have gotten the wrong answer, but please learn after today. This is the trick, all right? So I'm going to type here. So even though, all right, even though temperature stay the same during melting, but there's still heat gain. All right, so even though temperature stays the same during melting, all right, I can write during melting or during boiling. Okay, there is still heat gain. All right, I'm talking about during melting and boiling. All right, so this is a very big misconception. So if you find it difficult, you just ask yourself, I have a piece of ice. So obviously you must heat up the ice, or ice will gain heat from the surrounding, right? So definitely ice must gain heat to melt into liquid water. All right, if ice does not gain heat, there's no way it can melt. All right, so take note, it's a special case. It's a little special case. So the reason for that is the heat that's gained by the ice. Instead of using the heat gain to increase the temperature, the heat gain is used to sort of overcome the forces of attraction to change from solid state to liquid state. All right. So in order to change state, the heat is gained to change the state. Instead of heat is taken in to change temperature, heat is taken in to change the state. All right. So there is heat gain, but no temperature change. So here also the same thing. During condensation, temperature stay the same. Freezing, temperature stay the same. My question to everyone is there heat loss during condensation? Can you type in the chat, is there heat loss during condensation? Okay, well done.